This is the second video about bonding. This is entitled Covalent Bonding. Covalent bonding occurs mainly between non-metals, and the important feature about it is that, again, they're looking to get full shells of electrons, but this is by sharing electrons. So there's almost a double counting effect here. And again, we use dot and cross diagrams. Basically, what I'm going to do is work through some examples of covalent bonding. Now, covalent bonding, you can always tell on the GCSE question if it's covalent, because they will give you a diagram with overlapping circles. What you will have to do then is draw the final arrangement of electrons. So, starting point, we've got hydrogen chloride. So, using your periodic table, you can see there that hydrogen is atomic number 1. So, H1, it's got 1 electron in its outer shell. Chlorine is in group 7. So, you can see it's atomic number 17. So, if we look at these, hydrogen has got 1 electron, and chlorines will be arranged 2, 8, 7. Now, both need 1 for a full shell. So, if we take 1 electron from each, so there's your hydrogens. Here's your chlorine, and notice I'm doing dot and cross. The shared electrons go in the overlap there. So all the hydrogen electrons are used, and chlorines, we've got 7. 2, 3, 4, 5, 6, 7. So if we look at it this way, chlorine has got 8 electrons by sharing, and if we look at it this way, hydrogen has got 2 electrons by sharing. And that is a covalent bond. And we represent that like this, H bond Cl. A single bond there means, that line means 1 electron. Now, hydrogen, so moving on to the next one, hydrogen bromide. Hydrogen we know is 1, like so. Bromine, if we look at the periodic table, is in group 7. So if it's in group 7, it means it has 7 electrons in its outer shell. So just like chlorine, because it's got 7 electrons in its outer shell, it's going to do exactly the same. 5, 6, 7. So bromine's got 8 electrons by sharing, hydrogen's got 2. And we represent this as H bond Br. Now, hydrogen, if you remember, is one of those diatomic gases. And as we know, hydrogen is 1 electron in its outer shell, but there are 2 hydrogens. So if each shares their outer electron, they've both got a full outer shell. And we represent that, obviously, as H bond H. Now, moving on to fluorine. Again, we've got fluorine, like so. Now, fluorine, if you look, is in group 7 of the periodic table. It's atomic number 9, so it's F9, which means it is 2.7. So, for these 2 fluorines to get a full outer shell, each of them needs 1. So, as they need 1, they need to share an electron from each. Now, If they share an electron from each, that means they've only got 6 electrons left each. So 2, 3, 4, 5, 6. So you can see this fluorine has got 2, 4, 6, 8 by sharing. So it's got a full shell. If we do the same with the other fluorine, 1, 2, 3, 4, 5, 6. This fluorine's got 2, 4, 6, 8 by sharing. And again, it's deliriously happy. And we put this as F bond F. Now, getting slightly harder, but things you'll recognise. Hydrogen and oxygen. Now, hydrogen we know is atomic number 1. Oxygen, if we look at the periodic table, there's oxygen, it's atomic number 8. So, that means oxygen's electrons are arranged 2, 6. So it needs 6 electrons for a full outer shell. Sorry, it needs 2 electrons to get a full outer shell. So that means it needs to share twice. Hydrogen only needs 1 electron for a full outer shell. So it needs to share. If we put our oxygens here, and it's a total of 6 electrons, so we've got 4 more to put in. So if we look at this, we've got 2, 4, 6, 8. So everything again is happy, and we represent this like this: O bond H, O bond H, because there's a bond between each between the oxygen and each of the hydrogens. The last one I'm going to do is hydrogen sulfide. Hydrogens we know already, H1. Sulfur is 16. So if it's 16, it is 2, 8, 6. Now, as we know already, if hydrogen is 1, each hydrogen needs to share an electron to get a full outer shell. And similarly, sulfur, if it's got 6 in its outer shell, needs to share twice. So there. If it's shared 2 electrons already, it's only got 4 left. So 2, 4, 6, 8, and full outer shell. And again, we represent this with S bond H, S bond H, like so. Now, crucial thing here with covalent bonding, got to share electrons. You can identify covalent bonding because they will give you these overlapping circles for the electron arrangements. And if you use that to identify it, you won't go wrong. So, good luck everybody.